Hello, welcome to In 5 Minutes. Next example of a clamper circuit is as shown in the diagram. For simplicity, I am keeping the peak-to-peak voltage as 10 volts. That is in positive half cycle 5 volts, negative half cycle minus 5 volts. For simplicity, in all example, I am taking it as 5 volts for you to understand it better. Now, in the analysis of the clamper circuit, the first step is to see when the diode is getting forward bias. As per the polarity of the diode shown in the positive half cycle, the diode will get forward biased, and hence the capacitor will charge as positive negative in the positive half cycle. The polarity of capacitor is depending on what? The cycle in which the diode is getting forward biased, right? So where from the diagram, when you apply KVL in this loop, the equation will be KVL to the input. What will be the equation for KVL to the input? We'll have VI minus VC plus 2 equals to 0. Now in this case, this diode, the drop across the diode, if you are considering, what will be the change in the equation? VI minus VC, then minus 0.7 plus 2 equals to 0. This is the only change if the diode is considered non-ideal. The equation what I am writing is for the ideal diode, with which we are not considering 0.7 voltage drop, right? So from this, now in the positive half cycle, the input swing goes from 0 to 5 volts. So VI ka value is 5 volts. VC we need to find, plus 2 equals to 0. So the capacitor charges to 7 volts in the positive half cycle. This is how we have found the charge on the capacitor in the positive half cycle as 7 volts. Now at the same time, when I am applying KVL to the output side, what is the equation for KVL to the output? So when I am applying KVL to the output, since I need to draw the output waveform in both the half cycles, I am finding the output from that half cycle in which the diode is getting short circuited. Now when I am applying KVL to the output side, I will have VO plus 2 volts equals to 0. So I am getting the output voltage to be minus 2 volts in the half cycle, which is positive when the diode is short circuited. So I have got the charge on the capacitor. Our aim is to find the charge on the capacitor. And how to find the charge on the capacitor? We find the cycle in which the diode is short circuited. So we found the cycle in which the diode is short circuited, that is the first positive half cycle, the diode is getting shorted. So we found the charge on the capacitor to be 7 volts and output to be minus 2 volts. Right, this we have done the analysis of the positive half cycle. Now moving to the negative half cycle, that is our step 2. Next half cycle, what will be the change in the circuit? You are applying negative at this point and positive at this point. So with respect to the polarity of the input signal, the diode is reverse biased. That means it will be open circuited. So the circuit will look like you have capacitor, then the diode is open circuited. Then you have the voltage supply. It won't remove from the circuit, but it will become redundant since the diode is open circuited. You have the resistance R and the output plus minus VO, right? And the supply voltage now will have polarity negative positive, and the voltage is 5 volt. Charge on the capacitor, as we have seen in the previous step, it is plus minus VC, and the value of capacitor to be charged was 7 volts, right? So when you apply KVL from input to output, the equation will be minus 5, or you can say VI, I am considering as minus 5, then minus 7, that is the charge on the capacitor, or you can write for simplicity minus VI, then minus VC minus VO equals to 0, which will give you minus 5 minus 7 minus VO equals to 0. So you are getting VO as minus 12 volts. In positive half cycle, you got VO to be minus 2 volts. This was the case in the positive half cycle, and this is the case in the negative half cycle. So to total voltage swing from this, you can see it is 10 volts peak to peak, and the voltage swing of our input is nothing but 10 volts peak to peak, right? So the total output swing is 10 volts and input swing is 10 volts. That means our analysis is right. Now how to draw the waveform? Now see here, input is going from plus 5 volts to minus 5 volts. Then output is going from minus 2 to minus 12, which implies that the total peak to peak voltage ka value is 10 volts peak to peak. That means our analysis is right. This is how we are drawing the output waveform for the clamper circuit.